Perfect.
Go ahead.
This.
You should get a Twitch. We just chatting.
Use the chat.
We should have captain on. Check that now. What you said? You
Yes.
that link too. So I can test it.
Yes. Here you go. Thank you for coming down here. I really appreciate it.
Yeah. You see it?
You do?
I see it. Do you see my question?
Yes. I saw test. Yep.
Here we go. Do you want to see where you're at? You can just as we did.
You're perfect. Thank you.
Pretty good view.
Let's wait a little bit. It lags behind just a little bit.
Yeah.
And
Watch out with all these cords going on.
one more. I need to see some. Yeah, perfect. Wait, just a little bit. That's good. Yep, that's good. Thank you.
Mhm.
Yes, I always have to be careful of this because I also plug in the.
Why don't you just put that like right here? Then it'll be like directly, and it won't be a glare and stuff.
Smart. Got it?
Let me know how I can adjust.
This way. And the shutter is almost shut. Yeah, perfect. That's good. That's perfect right there.
Nice.
Thank you so much, Dennis. I thought Teams would be easier to use because
mask if you like.
Oh, good.
Oh.
Yeah. It's both at once. It's just the way it is. It's loud. Oh, hey.
Price checking in.
Awesome. Oh, we have 6 people. Cool. All right. Let's get the class folder in here. Okay. Just stand by while I get the rest of the class in here.
I didn't see anyone when I came down.
There's some people out there, but I'm not sure if they're from my lab or from my lab. All right. Hang on. Let me get you the temperature, please. Good to go? Good to go? All right, step on through. Good to go. Thank you. Come on in, let me get you. Welcome back. Cool. Really?
Yeah, let me know if you have any other issues.
Okay.
What's your favorite? I saw a lot of Trunks figures in the background.
Hang on a second. Let me get you what my temperature is. Right here. Neat. Okay. How many people we got here? 8 people on Teams. All right. Oh, now 7.
I just looked like.
Oh. It's like, I just praised them and they're gone.
Back on. There's what?
No, it's okay. Oh, let me get you. That's all right. All right, how you doing? Here you go. Hey. Yep, see you in about an hour. All right. We're going to get started here in a few minutes. Wow. See if this works. Cool. We have like an inception moment here. Yes, gaze upon yourselves, viewers. Ooh. All right. Cool. Okay, we're going to give it a few minutes to let some people come in. We got 3 more spots. Actually, check out Discord. Okay. God, the Wi-Fi here is trash. Utter trash. All right, here we go. All right. Those of you who are on stream, I will check in with the stream every now and again. I have to use both, so. Those of you who are watching, can you hear me okay? Coming through all right? Yeah? No? Kinda? I hope they can hear me. Awesome. Awesome. Thank you so much. Thank you so much. Okay. All right, we're going to wait another 2 minutes. How many of you have your lab manuals? Lab manuals. It's cool. All right, we'll get there. All right.
couldn't find it. I went to the wrong building.
It's completely okay. Completely understand. It's right here. Okay. I'm gonna pull the door shut because if I don't, my voice carries. The honors department will get my lecture also. Right. Okay. All right. Let's. Oh, very good. Okay. Let's get started. All right. So, I'm Mr. King. Hello. Welcome to my class. Yeah, we're going to make learning about rocks and earth processes as painless as possible. So, you guys have one benefit. I am a geographer. I graduated from here with my degree in geography, and I focus on physical geography. I like geomorphology, planetary geology, you name it. It's just who better to learn about rocks and the earth from than a rock nerd? So I will be helping you on your journey through this lab. All right. First and foremost, the lab manual. Let's just get this out. Rip the Band-Aid off here. Get a lab manual. Super important. This serves two purposes. One, it makes it very easy to follow along when I'm talking about stuff. I will be talking about things today, and I will do my best to step all of you through this in a simple way. Today we're just going to talk about we're going to talk about maps today. We don't get to talk about rocks. It hurts my heart. But we'll get there. We'll get there. All right. So get the lab manual. Super important. You're also going to reach a point where you probably won't be able to do the assignments without it. So please, over the next week, please get a lab. Okay, so let's go over the syllabus. Those of you who are watching on YouTube, I will not see your comments for the time being. So, all right. So here's the syllabus. So yes, I'm Mr. James King. That's me. Mr. King will do. If any of you know me, please, James outside of here, Mr. King in class. My email, do not send it to me on my school email. It might go 3 days before I respond. I'm just being very honest about this. It might go quite a while before I respond to you if you get my school email, so please use the one furnished on the syllabus. So yes, our class instruction will be in these 2 hours, and so I am going to continue to, since there are 3 teams, we're going to have like rolling attendance. So this week, I think your crew, is this the D team? D team doesn't meet next week. It'll just be J and K team next week. So you will be watching me from elsewhere, where next week, the K team, the people watching, will attend at 10 a.m. And the team that was there at 10 a.m. this morning will attend at 11 a.m. and so on. I'm basically rolling everything forward. So we're going to try that as there are 30 of you. And I'm trying to make sure everybody gets the proper time and attention and is able to get the proper instruction. My office hours on the paper in front of you that one of my fellow GTAs was nice enough to help me put together. Feel free to keep these if you want. Those are my office hours. For those of you, teams here, yeah. I'll give you guys these next week, those of you on teams. My hours are also listed on the syllabus. You are free to come visit me. Feel free. I have a nice, cozy home up in 305. You can't miss the door. We're the one with the giant map on the door. It also has all of my, I share the office with 3 other GTAs in the geography department. And you are free to come visit me. We will have to social distance, and that's fine. Or you can hit me up on Teams. Well, I just like Teams. We can find another way if need be. All right. So this course, we're going to talk about geology. We're going to talk about rocks and volcanoes and cool stuff. It doesn't sound cool sometimes, but I love it, and it's cool to me. So I'm hopefully going to make it interesting at the least. I like to be very physical when I talk about rocks. I will break rocks. I will give you guys things to do with rocks that will be like, tell me what this does, and it might entail dropping it to determine its specific gravity. It might entail breaking it to determine how hard it is. It might entail taking it and scratching something with it. But this is a lab where we are supposed to physically get our hands kind of in the dirt, in the rocks. And we're going to figure this out together. Now, I understand the concerns about Corona, so we will provide gloves and such for you when you do that. Also, this semester is the first semester where I cannot, actually I said this at the end of class, don't lick the rocks. Don't lick the rocks. It's a viable way to identify a rock, right? I mean, let's be real. Let's talk about all right. Let me show the live stream visuals. Yeah. So this is a bag of yellow rocks. All right. It's not kryptonite, I promise. I promise. All right. So these smell really bad. These smell really bad, these rocks. Had a student taste one 2 semesters ago. Yeah, that can't taste good. This is sulfur. This stuff ain't great. But yes, we will find ways to make this as interesting as possible. So, all right, moving along, the objectives are to learn about patterns and processes here on Earth that have to deal with geology, rocks, and the like. You will eventually be able to identify various types of rocks. And if I am, I don't know, doing my job, it should be fairly easy. And it might seem like a lot at first. When we get into the rock identification labs, it might seem like I'm throwing a lot at you, but everything that you need will be A, in the lab manual, and B, I'm always here to answer questions. That's just what I'm here to do. Okay. So, attendance. Listen, attend labs if you can. If you can. I know meeting in person is scary. I 100% agree that meeting in person is, I understand how that can be perceived. These labs, we have done our best to take precautions, and I am also going to ensure that we are as safe as possible when you attend. I want to make sure that everybody's health is considered. First and foremost, your health is paramount. Absolutely paramount. At no moment will I punish you for not showing up for class because you're not feeling well. Please communicate with me. That is something I need for all of you to do, is understand that the lines of communication between me and you are always open. I don't care if it's 3 in the morning. I do not care. Message me. You'll probably get a message back at 3 in the morning. So I was up till 4 last night. So getting up this morning was hard. All right. Okay. So attendance, show up if you can. I understand if you can. I really do. The assignments you have to do within the time period. But what I'm going to do starting this week is I'm going to start recording lectures. And this does not mean to not attend class. Because let me tell you that me talking about rocks for 20 minutes, as opposed to you coming in here and me being able to show you rocks and give you samples and specimens, and you can see the samples themselves and what they look like and how they interact and how they break and cleave and drop and so on and so forth. That experience is so much more fulfilling than just me talking to you at the camera for 20 minutes. So I'll do it. I mean, I'm going to. But if you miss class, don't worry. I got you covered. And if you need to schedule a point where you can come in and get your hands on the samples, there are really awesome rock kits around here. I think they're awesome. I don't know. My friends might show that. I think they're cool. Yeah, we can do that. So academic honesty, of course. Don't cheat. No, don't do that. So textbook and reading materials, you need the lab manual. Absolutely need the lab manual. I hate to harp on this again, but yes, please go get it. Let me swipe back here. Okay, they're good. Yes?
Is it actually in the bookstore?
It should be. Was it not?
I tried to do it twice and it wasn't there.
Noted.
They said you were aware of it.
I'm glad. Me. All right. So, yes, I was totally aware of that. I'm just asking you to be sure you knew. I'm going to check into that. Okay. So, yes, lab manual, super important. All right. Grading. Grading is, listen, the labs, don't miss a lab. Don't miss a lab. They are the largest part of the class. So don't miss a lab. All right. As you can see, they are 180 points out of 300. That is most of the class. Your final and midterm, they are not weighted. It is worth more to show up to class or to do the assignments. So please do. All right. Grading scale, you guys know about that. So COVID and attendance, again, remember, you guys come first. Like, that's very important. So again, communication. I'm here always. If you have DSS paperwork, let me know at the end of class, and so on. All right. Okay, so now that we're through all of that, okay, hello again, streamers. Okay. All right, so now we're going to start talking about the lab. So what I like to do is I'd like to start the class off with an icebreaker, a mind blower, whatever you want to call it. And this one is one I really like. It's called If the Moon Were Only One Pixel. So we're going to talk about maps today. And maps deal with showing an area of space in a graphic format or in a way that you can present information. So for instance, let's take this map of the Grand Canyon. All right, I'm going to hold this up so people on the stream might see me flip back and forth here. This map of the Grand Canyon. Okay. So this is a very nice map of the Grand Canyon. Very detailed. Lots of information here. And I'm going to use this map to step you through the pieces of information that you will need when you look at a map. And some of it that is missing. There is some information on here that's missing that might be needed on a map that aren't here. All right. So let's open up to... You know, that might make sense why I don't have it. Okay. Those of you following along in your lab manuals at home, this is on page 3 of the lab manual. All right. Okay. So this map of the moon, of the solar system with the moon as 1 pixel. Put this down. We're not ready for this yet. I'm going to have you guys give me some input on before we start. So what I'm going to do while I teach is I'm going to let this map unfold. And what this will do is this will move at the speed of light if the moon was a pixel. So if you were looking at our solar system, from the scale of the moon being only a single pixel, this is how fast light would travel. So for those of you also at home, you are free to weigh in here. I'm going to teach for roughly 25 minutes. Roughly. We'll talk back and forth a few times. It won't just be me preaching at you. All right. How far do you think we will get? 25 minutes. Don't Google it. Those of you at home, don't Google this. All right. I need a guess. I'll take a few. How far do you think we will get at the speed of light in our solar system in 25 minutes? What we got?
Maybe like Jupiter.
Okay. Okay. Jupiter. Good guess. What we got?
Probably being past Pluto.
Okay. Pluto. Good guess. What else we got? Anybody? Give me one more. Oh, don't be afraid. We'll be friends. It's cool. See people home? No? All right. What we got? Speed of light for about 25 to 27 minutes. What you got?
Mercury.
Okay, very good. All right. Nope, going to home. Okay. So, let's start then. So we're going to talk about the essentials of a map. We'll come back to this, by the way. We will come back to this. I will tie this all in, trust me. So when you look at a map, right? A map needs some very key things to be successful. The first thing it needs is a title. First thing it needs is a title. All right. This one has one up here in the top corner, and this is called the Bright Angel Quadrangle. And this shows us the Grand Canyon. This is a quadrangle right here. Let me move over here. Yeah, this is a quadrangle right here. So what this shows us is this map's title tells us that we are going to be looking at a map of the Bright Angel region that just so happens to include the very popular Grand Canyon. Has anyone been there before? No? It's super cool. Listen, it's one of those places you gotta see. Like, it's very cool. Okay. All right. The second thing you need is a directional reference. So a directional reference will include a compass rose, something that points its way to north. Now, there are two ways to denote this, and I will ask you, if you are considering something to be true north, what do we measure that against? What is the point that we say that's north? I'll give you a hint. Okay, very good, yes. And true north. What point might ancient navigators from 1,000 years ago use to navigate? That's right, North Star, very good. Yep, so that would be our true north. But we also have another north. We have magnetic north, which on this, it tells us is about 15 degrees off of true north here. And magnetic north is the area where the magnetic pole is. And we all know that over time, those shift, those move. They might even flip from time to time. All right, so we'll have that. Sometimes it'll be like a really nice graphic on there that just has like a point towards north. But it's just a way to show you how something is oriented. Now, let me ask you this. Let me throw this out there to you. Why might a map be oriented to the south? Why might you have a map that is oriented to the south? I know, right? It sounds counterintuitive. Okay, I have to look this up too. It's cool. So here is, let me actually look into the stream. All right. So occasionally, in the past, you would have ancient navigators that would have long, long journeys to the south. And because humans tend to have a directional bias, we like things to be in front of us. We like to have things to have a certain preset path. They would make maps that were flipped. So if you were sailing from the northern hemisphere to the southern, you would have a map that has the southern hemisphere at the top. And the bottom. These are really strange to look at. All right. Okay. So the third thing you need, and again, if I'm going too quickly, let me know. People on stream, I will check in on you occasionally. Let me know if I'm moving too fast. All right. You need a legend or a key. So a legend or a key tells you what certain symbols on the map mean. So if we were looking at, let's say, a map of the United States, what important things would we want a legend to tell us? What important points would we want to know? Okay, very good. What else we got? No? Okay, good. Yes?
Major rivers.
Okay, very good. What else we got? Give me one more. No? Anything? What you got?
Mountain ranges.
Hey, there we go. Okay. You're all right. You're all right. So you would want it to show you important parts. So if you are traveling to, I don't know, let's say Alabama to, I don't know, the capital of my home, Harrisburg, Pennsylvania. All right. Let's say you're going to Harrisburg. You would be like, well, where in Pennsylvania is Harrisburg? And you would look on the map, and you would generally see a circle with a star inside of it, and that would usually denote a state capital. That is the most popular notation. And you would cross a river. So as you get close to Harrisburg, you would see the Susquehanna River, and you'd be like, wow, there's a windy blue line there. Well, that's a river. And mountains also come into play. Mountains also come into play because you'll go over the Appalachians at some point also. All right. So it will have important information in a box somewhere on here. Now, I told you that this map is missing some things. Well, it is and it's not. This map doesn't have a proper key. It has a few notations down here at the bottom, but none of it is condensed into that box. But it does not have a proper legend or key on this map. It is still a good map. It is still showing you exactly what it wants to tell you. But this is missing that. You might see that on other areas, other maps that have it, but not this one. Don't think they have one here. Okay. All right. We are also going to talk about the source. Let me check it on the screen. All right. The source is very important. Now listen, when you look at a map, I have a professor who likes to say that maps lie to you. And they do. Why would a map lie to you? Let me hear what you got. Anyway, why would a map lie to you? Let me throw this out there further. We're heading into an election season. Why would a map lie to you? Okay, very good. That's exactly right. Okay. A map source is incredibly important because, as you said, people will present data in a way that might be skewed, or it might be biased. We're definitely seeing this in election seasons right now. Oh, that's us. All right. So, a map source is incredibly important because when you look at the map source, you know that if it's from, I don't know, a map of where all the dogs are, but it's made by cats, you know that it's probably not going to be a nice map, right? All right, you know, we have a basic idea there, or we can apply that to other two-party systems, if you will. I'm not going to try and stir the pot here, but you can definitely do that. You know, and you will have certain parties that will attempt to show you information in a way that garners support for what they want to show you. And that is why it's very important to think critically and look at the source on the map. It's very important to do. Okay. I'm not going to harp on that too much. All right. It is also important to notice the date. The date on the map is very important. So if I showed you, and I will talk about this here, if I showed you an election map and you looked at it and you were like, wow, that looks great. And you saw a bunch of red states and a bunch of blue states, and you saw that, you know, maybe there were a whole lot more blue than red, you'd be like, wow, that election went great for said blue team, right? But then if I said, oh, hey, that was from 1960 when John F. Kennedy got elected, you'd be like, oh, wow, yeah, that doesn't have any bearing on today right now. You know, it would be a much different map than today. It wouldn't be as relevant to the information I'm trying to show you. Because if I showed you at this election season, if I pulled out a map of the 1960 presidential election and I was like, yeah, look what JFK did, you'd be like, yeah, great. That doesn't really have any relevance right now unless we're talking about history. So the date is very important. And take note of that. This one, and let's see this masterpiece right here. This is a map of Jacksonville. All right, so Jacksonville and the surrounding areas. Okay, this map is really old. This map does not have a lot of things on it. If you were to, I don't know, I think Gamecock Village isn't on here. So if you live in there, this map basically says you don't exist, which is weird because it was made in the 70s. So this is a really old map. There are things that don't exist here. There are things that exist now that are not here on this map. All right. So this is a very old map, even though it's not in Jacksonville, even though it has JSU. It has the square. It has very important features, but it still is not as relevant because 50 years later, the town has changed. All right. Okay. On top of date, you also need to know the name of the cartographer. So in this one, let's put this one in. In this one, the name of the cartographer it is not stated, but it tells you that the U.S. Geological Survey was the one that did this. So we usually be giving credit to the people who created the map. This says that it wasn't just one person that created the map, but probably a team, definitely a team. All right. Okay, so we're going to get into the last two parts of what maps are, and we're going to get into this a little bit more also as we talk about that. What are we at? 11 minutes? Very good. All right. We're going to talk about projection. Okay, so when we talk about projection, we have to talk about distortion. Those two things go hand in hand. Projection and distortion go hand in hand. Why is this map distorted? I'm going to look at it on the screen for a second. All right. Why is this map distorted? Anybody? I can give you a hint. You guys want a hint? Why is this very flat piece of paper distorted? What's that? You're close. We're almost there. Yes.
Doesn't like show like the height.
Also very close. We're getting there. Why is this flat map distorted? Look at the stream. What's that?
The Grand Canyon isn't flat.
True. We're almost there. We're so close. We're on the precipice of greatness. What do we have?
Does it just make it easier to follow?
We're so close. You're almost there. You're almost there. Why is this flat map not? Why is this distorted? Close. We're right there. We're so close. What we got? What do we got? Let me check it on the stream. The Earth's not flat. The Earth isn't flat. That's why this map is distorted. This is a very accurate map. This is a very well done map. But the Earth isn't flat. That is why this map is distorted. This map essentially lies to you. Now, I'm not saying like, oh my God, the map is trash. Throw it, burn it, how dare. It's not like that. But this map is distorted because it's flat. All right. So there are three types of distortion. Those of you following at home, we're on page 8 of the lab manual. If you have it, sorry I haven't been mentioning that. Okay, so I want to talk about distortion in direction. All right. So if you look at a map of the Earth, right? Look at a map of the Earth. We don't have one up here in front. There's one in the back, but so if I were to ask you what the shortest point from, let's say Montreal in Canada, right, was to Finland, what would you say? Okay, right. But what would that entail? A straight line where? See, here's where this projection distorts things. It shows you Montreal, which is right over here in Canada, America's hat, right? Okay. So you might think that going straight across the ocean is the quickest route because the shortest point between any two, first line between any 2 points is a straight line, right? Okay, we know that. On Earth, that is not always the case. And here, we know that many pilots who fly actually take a curved path because it is shorter. Sometimes even going into the Arctic Circle. They don't go straight across, they take the shortest path. And the shortest path is actually curved because the Earth curves. But if you were to look at a flat map, if you were to look at that flat map, it would look like, and there's one in the back there for those of you who can see it, the flat map in the back makes it look like the shortest point would be a straight line. Makes it seem like going up over the Atlantic Ocean, over Greenland, and into Finland from the north would take longer, but it doesn't. But it doesn't, and that is how maps distort direction. A projection will distort direction. And here we're also going to talk about distortion in area and shape. And here we're going to focus on Greenland. Greenland is probably the biggest offender for distortion in shape and area. They go hand in hand, but we're going to talk about area first. So sometimes a map will show you something from an almost biased perspective, right? So if you are creating a map for people in the Northern Hemisphere, you will want to show features of the Northern Hemisphere. You will want to highlight those features. And therefore, because you want to do that, you want to make the features larger. This is a very simplified explanation of this. But what that means is that you may see land masses in the Northern Hemisphere that are much larger than they are. And Greenland is the biggest offender of this. Greenland is such a hard thing for people to map because there are so many different projections that people look at that and they, most of the time, and this is a sweeping generalization here, but most of the time think it's larger than it actually is. Yes, it's a large island. It's a large landmass, yes. But maps tend to distort Greenland by making it larger than what it is because of the bias of the Northern Hemisphere. And this is where you also get into a distortion in shape, is when you start changing the area of something, you start changing the shape. And therefore, that makes it difficult to properly map the area. So when we talk about distortion, distortion in direction, distortion in area, and distortion in shape. And that is one where when you do your lab assignment, look at a globe and look at a flat map. And each one of those will show you exactly how the distortion occurs. Even pull up a flat map of the Earth, and most of the most common projection of the Earth that we see is the Mercator projection, and it heavily favors the Northern Hemisphere. The land masses are much larger, whereas Africa also tends to be distorted, but South America tends to get shaped strangely. Okay. All right. So now we're going to talk about scale, and I'm going to tie back to this, I promise. So there are two types of scale that we're going to talk about. There are more, but we're going to talk about graphic scales. Graphic scales, and this is like bar scales. So let's pull out. Pull out our handy map of the Grand Canyon. Let's pull out our handy map of the Grand Canyon again, and you see down here at the bottom, right? Down here at the bottom are bars. And what you can do is you can take a ruler, or you can take any measuring device, put it against that, and put it on the map, and accurately get a sense of distance. Okay, that's what a bar scale does. And there are multiple here. There's one for kilometers, feet, and so on. Okay. You also have a representative fraction. And representative fractions can be a little tricky. So you'll see one that says this one is 1 to 62,000. That's it. It's a ratio. 1 to 62,000. Because all scale is a ratio of Earth space to map space. That's all it is. That is scale. It's in a nutshell, in like what? 5 words? So when it says 1 to 62,000, my question for you, I'm going to put the stream here, is 1 to 62,000 what? What are we measuring in? Miles. Okay, very good. What else we got? More guesses. What we got?
Kilometers.
Okay, very good. What else we got? One more. Come on. I take things in threes. Come on. What we got? Miles? Kilometers? More guesses. More guesses. Nah? It's cool. All right. You want to see my guess? Rocks. That rock. We'd all be right. Miles. Kilometers. That rock, which I like. That's rhyolite, by the way. You'll get to know that. All right. What that RF means is that if you measure 1 mile on this map, which would be very difficult to do, you could do it. It would be a decimal, a pretty small decimal. If you measured 1 mile on this map, it is 62,000 miles in real space. Now, obviously, you would be around the Earth twice, but it works. Kilometers works. That rock works. If I put this rock to this map, and I say, how many of this rock would this map equal? 62,000. That's what it would mean. So the representative fraction can be representative of anything. Take off your shoe, put it on the map. Go ahead. It's fine. You browse Reddit, take a banana. Bananas for scale are good. You do that too. All right. It doesn't matter. So the RF is unitless. You give it the unit. That's what you do. But it must be one of that unit to 62,000 of the units on the map. That's how the RF works. Okay. The last thing we're going to talk about, and we're going to tie it back to this. How far are we here? What's the last thing we saw?
That's the last thing I saw.
Just got we're farther than that. 21 minutes. We've got to be on our way to Jupiter by now. All right. If I were to show you, let's bring this back. I'll need this. If I were to show you this map and this map, and don't be fooled, this is a map. Which one of these is a larger scale? Which one of these is a smaller scale? Yes?
Smaller scales, the Grand Canyon.
Wait, say this one more time. Oh, let me start here.
Smaller scales, the Grand Canyon.
Okay. What you got?
That's larger scale.
Okay. Tell me why. What's your reasoning?
It's a smaller space map.
Okay. Tell me your reasoning.
That cuts down the size of the universe a lot more than that. That cuts down the size of the Grand Canyon.
Class, which one of them do you think is correct? You ready? You're right. It was a very good guess. It was. So, look at it like this. If I put these maps next to each other, and you try and find yourself, right? You will appear larger on this map. When you think about scale, put two maps of different sizes against each other and ask yourself, if you were to look for yourself on this map, on which map would you appear larger? You would appear larger on the Grand Canyon because you can see more detail. There's more to look at. Now that seems strange because this is the smaller map. This shows a smaller area, but it shows a larger amount of detail. This is a literally astronomical map, like astronomically sized, quite literally, but shows you very small details. Earth, Sun, Mars, asteroids. That's what you'd see. Very, very small details. If you were to try and look for yourself on this map, you would be infinitesimally small if the moon was just a pixel. You would be a billionth of a trillionth of a percent of a pixel on this. Very small. Where on this one, you would appear much larger. Imagine it like this. If we are standing here in Martin Hall, and we see somebody walking along the street, which, well, what a terrible day for that, but some of us have to. So you would look at them and you would say, oh, hey, that guy's got a black shirt, and I think he's got glasses, and he has impeccable hair. Oh, what a nice guy. You'd see that and be like, you could make out the details, right? But if you were to see the same person at Bib Grace from here, you couldn't make out the dark shirt. Maybe you could. You couldn't see that that person has glasses or very nice hair. So. Okay. So you know that that person appears very small in the distance. The person here appears much larger. So yes, if you are confused about scale, put two maps against each other. Put two maps of various sizes against each other and just ask yourself which one you appear larger in. And that will tell you that that is a larger scale and the other is a smaller. All right. Okay, let me go back to the stream for a second. Do we have any questions? Any questions at all? Listen, don't be afraid. It is okay to ask me questions. There are no stupid questions. So, seriously. I don't care. No? All right. People on stream, do you have any questions? Cool. I will take that resounding silence as a no. Okay, so what I want you to do is there is an assignment on Canvas. Do it today, soon. I haven't looked at when the due date is. I believe it's later today. Please do the assignment. If you have trouble, if you are struggling, please let me know. I am here to help. That is my job. And as I end this class, I want to let you know that if you need help, I'm here. Do not hesitate to hit me up. I will get back to you as soon as I see it. I do have some classes today, so it might take me a little bit at some point. But do not hesitate to ask me for help. I'd even venture to say if you are struggling in your class, if you are having trouble with geology, I'm here to help. I will do whatever I can to help you understand something. And I understand that tutoring services aren't really a thing right now, or maybe greatly diminished. But please, it is my job to see that you make it through this lab. And as this lab is so closely tied to your actual class, I will help you in any way I possibly can, because if I help you understand the things that you're also learning there, it will translate here also. It would be much easier for you to understand the material that I'm teaching you. Okay, so again, to finish up here, who said Jupiter, by the way? Yeah, look at you, on a roll today. All right, yeah, we're almost there. Okay, oh, Pluto, by the way, I like this one. If I were to let this run, if I were to lecture at you until we reach Pluto, ready for this one? I like this one. And we're going. And we're going. I'd have to lecture for 328 minutes. That is, man. Yeah, it is. I mean, I think I don't know if I could lecture for 5.5 hours. I think we just go from like Dragon Ball to like more geology, back to Dragon Ball, and probably some other anime that I watched recently. So, we hit D&D at some point. Anyway, moving along. I'm digressing. Okay, so let me know if you need help, and that's all I got for you. Thank you, those on stream, for bearing with me and attending. And do the assignment that is on Canvas, and hit me up with any questions you have. Next week, the D team will not show up. The D team will be on Teams. That's this class. Yes, you're on Teams. The J team and the K team are going to show up for class. I will put those on Canvas. Please look at the announcements. All right, have a great day. I'll dismiss you here one at a time. You're free to go. Yeah, you're good here.
I don't see the.
Neat. Thank you.
I looked at all the sections.